Welcome to Economics Wise. Our course for today is statistics and we'll be taking test of hypothesis. Test of hypothesis. Hypothesis is simply a claim, guess, suggestion, unverified, tentative, testable statement of possible relationship between two or more variables. I could say one word now and it's not a fact. Anything that is not a fact, that is unverified, it is not it hasn't been proved, is simply under hypothesis. So when I make a claim, a guess, a suggestion, something that is unverified that I want to put to a test, it simply refers to as what? Hypothesis. So hypothesis can only become a fact, a theory, or can be accepted only when it has been tested and proved to be verified. So it's when you just make those statements, they are simply assumptions without facts or without proof. There are three main ways of stating hypothesis in statistics. We have the null hypothesis, alternative hypothesis, and the simple hypothesis. The first to be taken is null hypothesis, and from the word null, it means empty. It's denoted by HO, that's H subscript O, and you can also call your null hypothesis to be an hypothesis of indifference. This hypothesis simply states that there is no significant difference between two variables, and as such, it is usually stated in the questions, and you are asked to test if this statement is true or is false. However, if it is true, you are going to accept or you would fail to reject your null hypothesis, and if it's false, you reject your null hypothesis. Alternative hypothesis is simply the opposite of the null hypothesis, and this hypothesis it shows and takes into considerations every property of this simple hypothesis. So it shows what's the exact relationship between these variables. If null hypothesis say there's no statistical difference, then alternative hypothesis will tell you that there's a statistical difference. So simple hypothesis is more or less like a statistic or a test of hypothesis that just shows a relationship between a variable, but it does not tell us the nature of that relationship. And in that context, I mean, it could tell us if it's positive or negative, but it doesn't tell us what are those underlying facts that support it. If it's actually, it doesn't undergo a test, let me put it that way. Heading to our next slide, I'd like to explain the concept of type 1 and type 2 error. I'd stated earlier that your null hypothesis shows that there is no statistical difference. As such, when it is true and you reject this null hypothesis, you've committed an error, which is the type 1 error. However, when your null hypothesis is false and you reject it because yes, it's false and does not conform with this basic fact or proof, you've taken a correct decision by rejecting that null hypothesis. When your null hypothesis is true and you fail to reject also, that's a correct decision. But when it is false and you fail to reject it, you've committed a type 2 error. There are different steps to solving hypothesis questions, and the first is state your hypothesis. You have your null hypothesis and your alternative hypothesis. The next is to state your critical value. Your critical value depends on what type of test, if it's a t-test or a z-test. However, your t-test is usually used when your sample size is less than 30, and z-test is mostly used when your sample size is more than 30. So the next step is to compute your z or t statistics. And when I mean z or t statistics, I mean your calculated value given the formula. Now, the next is to compare the critical value and the statistic value. When I say your critical value, I mean the value you've gotten from your z table or your t table, compare it with the calculated value, and this will lead you to understand the next step, which is to draw your conclusions. There's a decision rule when taking decisions, and the rule states that you reject your null hypothesis when your z calculated is greater than your z tabulated. When the value you've gotten from calculations is greater than the value you've gotten from your table, you reject the null hypothesis. However, when less than your z tabulated, you fail to reject that null hypothesis. You don't actually say we accept, because it's saying there's no statistical difference. However, it can also be said, but it's not really a proper. We just say you fail to reject your null hypothesis. We're going to take an exercise, and the exercise reads that the researcher claims that the average number of disabled persons who come for checkup spends an average of 18.9 hours in a month. A sample of 200 patients has a mean of 21 and a population standard mean deviation of 5. Test the above claim at 5% level of significance. The formula to solve this from our question, we see that our sample size is 200 patients. So we are using the z-test. And the formula for our z-test is the S bar, which is the sample mean, minus the U, which is the population mean, divided by your standard deviation, which is also divided by the square root of your sample size. That being said, I'd like to take us through the solutions in accordance with the steps I've listed previously. To state your null hypothesis, the question says that the researcher claims that the average number of disabled persons who comes for a checkup spend an average of 18.9 hours in a month. So this is telling us that there's no statistical difference, but they spend 18.9 hours. It's not telling us if it is more than or less than, but it's telling us strictly that it is 18.9 hours. So our population mean is 18.9 hours. That's our null hypothesis. While your alternative will state that there is a statistical difference, it's either it's not up to 18.9 or it's less than 18.9 or it's greater than 18.9. Having stated that, the next one is to check for a z critical value, which is also known as the z tabulated value. And we check this using the 0.05 level of significance. And since our question is a two-tailed test, and in terms of two-tailed test, it means that we either have it to be less than or greater than. So having checked that, we have our value to be 1.65. We compute our z statistic, which is computed and using the formula, and you should get 5.94. I want us to do this together. Sorry I couldn't solve everything out because it's kind of bulky. A decision rule from this is that when your z statistics is greater than your z tabulated, you reject null hypothesis. And from our z tabulated or statistics or z tabulated, we have 1.645, and our z statistic, which is the calculated, is 5.94. However, we can see that our z calculated is greater than our z statistics critical value, so we are going to reject the null hypothesis that states that the average number of disabled person who come for checkup spends 18.9 hours in a month. So this is telling us that it is not true. People don't spend up to 18.9 hours. It's either they spend more than or less than. And that's all for test of hypothesis. So it helps us. Now we can now say this as a fact that people don't spend 18.9 hours because we've tested it. However, when we haven't tested it, it is still an assumption. It's a claim. It's unverified. I hope you understand this. Please like, comment, and share, and subscribe to my channel. Thank you very much.